Welcome back. Modeling with quadratic functions. May real-world situations. I'm a typing menace. Many real-world situations can be modeled using equations of quadratic functions. For example, curved arches are common in architectures, design of building, bridges, and other structures we encounter. These curves may be approximated by parabolas. In previous sections, parabolas can also model the path of projectiles as they fly through the air. In business and social science, quadratic models can be used to analyze trends. So in other words, quadratics are in the world and we need to know how to deal with them. Example 1, find the equation of a graph. So here's a situation where I'm going to give you a graph and I want you to come up with the equation of it. The graph models a parabolic cross-section of a skateboard half-pipe. So you hop on here, you skate down, you come back up, you do the loop-de-loops, you pretend you're Tony Hawk, and you come back down and you go back up there and you do all sorts of cool things. So what we want to do is we want the equation of this so that we can set up our computers and our machinery to be able to build it and to find the optimum dimensions for it. Depending on the curve will depend how fast the skateboard can go, and so on and so on and so on. The physics of it. So in the graph, the x represents the horizontal distance from the platform. So there's a platform here. This is the platform. This is the distance away from the platform. This is the height above the ground of the platform. So in other words, Tony Hawk is standing right there with his skateboard ready to go on top of the platform. And he's about to do some wonderful things jumping in here. Okay. Determine the equation that models this. So we have three forms that we can use. We can use standard form. We can use vertex form. And we can use factored form. The easiest form to use in this situation and be able to get what I need is the one where most information is provided in the problem. Do I know what my vertex is? I do. They give me the vertex. That means I have an h and a k value. My vertex is given by 6, 0.75, which means that h equals 6 and k equals 0.75. Those values can be subbed into that equation, giving me y equals a x minus 6 squared plus 0.75. Now I'm not done yet, because for this to truly be the equation, I need to know what a is. I don't know what a is. Good news. If I'm able to get any other point such that x and y are given, I can find a. So picking any other point on here, how about 2, 4.75? That means when x equals 2, y equals 4.75. So I'm going to plug them in. 4.75 equals a bracket 2 minus 6 squared plus 0.75. that is going to allow me to solve for a. So I'm going to get 4.75 equals a minus 4 squared plus 0.75. 4.75 equals a times 16 plus 0.75. Take the 0.75 over to the other side. Four equals 16 times a. Not sure why I'm writing on a diagonal, but I am. We're going to divide both sides by 16. First I'm going to change it so it's in a form that you're used to, and I'm going to make it level because I'm starting to get seasick. I'm going to divide both sides by 16. A equals 1 over 4. You know what that means? Therefore, the equation is given by and I got it by knowing the vertex and any other point on the curve. And that's how I solved for it.